Next, we're going to look at solving a polynomial inequality algebraically. And most likely, this is what's going to be required on the final. This is mostly what your homework is like. Again, when you have an inequality, you want to be comparing to 0. You don't want to compare something like x to the fourth to x or x to the fourth to some other number. You always on the inequalities want to have your expression on one side, all your variables on one side, and 0 on the other side. So the way to do that here is to subtract x from both sides. Do not divide by a variable, because in that case you would lose valid solutions when you do that. So the first thing we want to do is write that inequality with all the x's on one side. Remember that the only way for a polynomial to change sign from positive to negative or from negative to positive is to go through a 0. Just because there's a 0 doesn't mean there's a change in sign. What we want to do is find those zeros first. In order to do that, we need to factor and then find the x-intercepts. We've been working on this, so if we factor that difference of cubes, that gives us the x minus 1 times the x squared plus x plus 1. And then we also have that factor of x that we factored out in the beginning. Each of these factors are possible zeros, so you're going to take each of the factors and set them equal to 0. Again, things that we've been doing for a while. And then you see that if x is 0, that gives us one of the zeros. If x minus 1 is 0, then x equals 1. And this quadratic right here that we got from factoring the difference of cubes is not going to factor anymore. So we can't factor this. We don't need to even try. We can kind of think about it a little bit and see that if x is some number and I square it, that's always going to be bigger than x by itself. At least it'll be the same thing or bigger. And then I'm adding something to that. And so because of the plus 1 here, it's always going to be something that's positive. Now, if that logic doesn't make any sense to you, you could always try to put that in the quadratic formula. And when you put it in the quadratic formula, you'll find that you get imaginary answers, which are not valid for polynomials and things that we're graphing on the typical coordinate plane. So our only zeros are x equals 0 and x equals 1. We want to use these zeros and divide our number line into intervals based on these zeros. So these are the intervals that we would have from negative infinity to 0, from 0 to 1, and from 1 to infinity. It's a whole lot easier to put these intervals, to work with these intervals on a number line, so that's the way we're going to do those. On the next page here, we're going to draw a number line. And we're going to put those zeros in order. So we had a 0 at x equals 0, and we had another 0 at x equals 1. And that divides our number line into those 3 intervals that we just saw on the previous page. Now the polynomial has a domain of all real numbers, so I have an arrow on both ends saying that it goes on forever. These are the only zeros that this polynomial function will ever have, and it's defined everywhere. Okay. Now what we want to do, remember this x to the fourth, we subtracted the x from both sides so that we could compare to 0, and then we factored this. So we had x times x cubed minus 1, and that was factored into x times x minus 1 times x squared plus x plus 1. And we said that this factor right here was always positive. If a factor is always positive, then you can just ignore it because it's not going to impact your answer at all. But what we want to do is take these factors that could be positive or could be negative, and we want to test them on each of these intervals. So we're going to list out to the side, we're going to list x, and we're going to list x minus 1, just each one of those factors. If I had more factors, I would list more factors down the side. And I want to test those on each interval and see if they're positive or negative. So you can pick any number that's on this interval, any number that's less than 0, and you'll get the same result every time. So I'm going to pick negative 10. If I put negative 10 for x, it's going to be negative. The only thing you're interested in is whether it's positive or negative. I could put negative 10 into this next factor, and negative 10 minus 1 is going to be negative. Keep in mind what's happening with the x and the x minus 1. They're being multiplied together to give us our function value. So if I multiply a negative factor and a negative factor together, then the function itself the y values are going to be positive on this entire interval right here. Now between 0 and 1, I want to do the same thing. If I pick a number like 1/2, if x is 1/2, then it's positive. If I put 1/2 in for x into the next factor, then I get 1/2 minus 1, and that's going to be negative. If I multiply a positive factor times a negative factor, then the y values are going to be negative on that entire interval. Pick a number that's bigger than 1, like 10 or 100, any number you want that's bigger than 1. And if you put it in for x, it's going to be positive. If you put a big number in for x here, like 10 minus 1, still going to be positive. And when you multiply a positive factor times a positive factor, you're going to get positive y values back. Now look back to what we were looking for. We wanted y values that were greater than 0. There are no equal signs on here, which means we're going to use parentheses exclusively. So we're not going to use our zeros, but go right up to them. And we want greater than 0, which would be above the x-axis, which would be positive y values. So we want to shade here, and we want to shade here where we get the positives. Now it's easy to get lulled into a sense of security of alternating signs here, but that doesn't always happen. If you watch the previous video when we were looking at the graph, there were 2 zeros on there, but there was only a change from negative to positive at one of the zeros. On the other 0, it was positive on the left and the right hand side because the graph touched the x-axis and went the other way. So there was no sign change. So they're not always going to alternate. Sometimes they do, sometimes they don't, and you just have to test. So our number line, and this work right here is the work that they'll expect to see on the final and on your written homework for solving an inequality algebraically. But to write the answer, you just need to use interval notation is probably the easiest. We want to start at negative infinity. We want to include all the numbers up to 0, but not including 0. And then we want to start again at 1, and we want to include all the numbers to infinity. So if we have 2 detached shadings on our number line, we're going to have 2 detached parts on our interval notation.